All right, welcome. So, for those of you that are new to Bing Maps for Enterprise, we're going to start with a little overview there, and then move into the fleet specific stuff. And I promise to move through this through the overview quickly because we have a lot of exciting new stuff to show you. But roughly, here's the agenda that we're going to cover. A quick look back at the core mapping platform that's part of Bing Maps for Enterprise. Then we'll look at the new APIs that we've released over the last 4 months that we've been saying are really optimized for fleet management. But as you'll see, you can use them in other industries as well. But together they really form a powerful grouping that has really taken off in fleet management, transportation, and logistics. And there you'll see these new APIs are for truck routing, distance matrix API, isochrones, and snap to road. Then we'll take a good amount of time looking at our Bing Maps fleet tracker. This is a complete tracking solution that we released as an open source solution in January. We'll show you how you can deploy it yourself, be up and running basically with a real-time tracker in about 10 minutes. And then we'll just give a review of how to get started. We'll show you how to create an API key if you're really starting with the very basics, provide links to our code samples and all that stuff. And I want to start with a reminder. This is mostly for those that are in the US. We will be at the North American Fleet Association show. This is coming right up at the end of this month, April 24 through 26 in sunny Anaheim. So even if you are far away, but you've been thinking about a trip to the US, it's a nice time to make it to Anaheim. They got Disneyland down there. And we'll be showing all of this stuff that you're going to see here from the comfort of your office, but we'll be showing it on the show floor at the Fleet Association event. All right, so here's that overview. What good would all these new fleet management APIs be if we didn't have good core mapping? We do truck routing now, but you're going to want to display that truck route. So, we have all of the basics covered. We've been doing this for a long time at Microsoft. The team I work on is about 100 engineers working on mapping. We've been doing this for just about 2 decades now, going all the way back, as you can see here, to Encarta in '93. That's before my time at Microsoft. I came in the early 2000s, and I feel like an old man doing mapping here, but we've got some folks still on the team that have been around longer than that. Our mapping platform is used in just about every industry vertical. And I think this last bullet here is really important. We continue to invest heavily in this space. This isn't something that we take lightly at Microsoft. We've been investing in it for decades, and we continue to do so, as you'll see coming up with the innovative stuff that we've been adding to the platform. So when I talk about the Bing Maps platform, it's really comprised of this suite of RESTful APIs, REST services, along with our map controls. And we've got a JavaScript map control, and we've got a Windows native map control. And together they provide everything you need for your core geospatial needs. And that's the point I was making a moment ago. What good is a mapping platform with advanced APIs for fleet management if you don't have the basics like geocoding, reverse geocoding, traffic, good data visualization? That's all built into the platform. So we're not going to cover that stuff in great detail today, but it's really important that you understand that it's there and available as part of the platform. We are a global organization. When it comes to mapping, we support well over 150 countries, and there's only a few exceptions to that. And I'll talk about certain APIs like truck routing, where we don't have enough attributes to have it in every one of these countries, but I'll show you the country list. So when there's an exception to how many countries we support, I'll call that out along the way. But it's important for you to know many of your businesses are global in nature. You're not just working in the UK, you've got business in France as well. We've got the world covered with mapping and geospatial services. And we're also really well known for our world-class support, documentation, and sample code. We put the emphasis on enterprise. We're not a consumer mapping product, although at Microsoft we do have a consumer mapping product. You can go to Bing Maps and try that out. But when it comes to enterprise, we take our enterprise customers and developers very seriously, and we're very well known in the industry for our support. This is a quick look at some of the stuff. Again, for those of you that have been working with our platform for a while, this is mostly a review. The version 8 map control came out, it's almost a couple of years ago now. And these are some of the features that were added at that time. So they're all standard features now, but you can see some of the things we've talked about: traffic, heat maps, clustering. And these little thumbnails are fake examples. The clustering looks very uniform there because that was made with fake data. But the idea is, if you have a lot of corporate data that you need to see plotted quickly with just a few lines of code, you can do clustering, you can do heat maps, you can do shaded maps. We have custom map styles. You can make the map look exactly how you want it to. You can see the example here of a black and white map. Maybe you want a neon purple map. That's fine. You can completely customize every element that is on the map. And the last thing that I'll mention as we're looking back at the core platform is the GeoXML module, which we added last year. And this is what allows you to import data from industry standard file formats like KML, which is the keyhole markup language made popular in Google Earth, KMZ, which is the compressed version of that, GPX, GeoRSS, a whole bunch of file formats. You used to have to write a lot of code to import this and make them interactive objects on your map. But when we added this module into the map control last year, it just became 3 lines of code. It's very performant. You can load very large files, and it makes it really easy to get data from industry standard formats into the system. Okay, so that was our quick review. Let's move into some of the new stuff, the 4 new APIs that we've been talking about: truck routing, distance matrix, Isochron, snap to road. Those are all out. They're part of our production platform today, and we're going to have a look at each of them in order right now. And there's also a time zone API coming. And boy, I could have used that time zone API this morning, because I know you just had daylight savings. You're on British summer time now for those of you that are in the UK, and that threw me off by an hour. I was almost going to pop in here at 8 a.m. my time. So fortunately we caught that, and I got on board here at 7 a.m. And I made this point earlier that these APIs, we're talking about fleet management and logistics today. But it's amazing how after we release these APIs, how people in other industries have been using them: commercial real estate, insurance assessment. They've been using distance matrix and Isochron quite a bit. So they're not just for fleet, but that's what we're going to focus on today. So let's start with truck routing. I like to start with a funny picture. You see stories like this online all the time. A truck that was following driving directions from a consumer grade GPS. And if you work in that industry, you know that trucks can't go everywhere where cars can go. We're going to look at some examples of that. And if you are using an API that creates car routes for trucks, you're going to run into problems like this. So why truck routing? Why is it different? Well, think of all the limitations that trucks face. They might be too tall to go under a bridge. They might be hauling flammable materials, so they're not allowed to go through a tunnel. They have to be careful of steep gradients and sharp turns. They've got to worry about things like grounding. There's restrictions that are imposed on them for number of trailers and number of axles. Different roads have different speed limits for trucks. All of these add up to be a nightmare if you're using car routing to optimize your truck routes. So what do we do for truck routing? So think of any routing problem as a cost problem. You have a bunch of roads in a network, and you want to know which roads to cross. Each segment of that road network has a cost associated with it. And what we do is we use these attributes to basically put a cost on the route, an internal cost, not a dollar cost. And you can see that drawn out here for consumer routes. The quickest way to get from point A to point B, and this is in Seattle crossing Lake Washington, is from approximately where I live up to north of Microsoft, it would be to go over the 90 bridge and go up the 405. But what if I had a limitation and I said, I want to avoid highways, as a for instance? You can see that the trip goes from 33 minutes to 58 minutes. For consumer routing, we only support two of these limitations, avoiding tolls and avoiding highways. But now you can imagine the same system, but with a whole bunch more restrictions brought in. What if one of those restrictions was I'm hauling flammables? I wouldn't be able to go through that I-90 tunnel there because they don't allow flammables to go through there, as a for instance. So let's look at some more of those. Someone asked as we were getting started about low bridges and obstructions. So this one happens to be the picture that you're looking at is right near my house. I go under that bridge. It's a 9-foot bridge every day on my way home. And just coincidentally, about 6 weeks ago, I just missed seeing an accident. This picture is older, but it happens all the time here because this bridge is right off of a major highway. So a lot of truckers in very large trucks take that exit, and they don't know that they can't cross under here to get into downtown Seattle. I've seen people having to do very awkward 10-point K-turns to get out of here, and now I've seen someone actually smash into the bridge. So it is just one example of the type of attributes that we cover with our truck routing. You can see a whole bunch more here. Our documentation lists all of these in detail, but I called out a bunch of them for you to look at here. And we're going to look at a demo in a moment where we can play around with some of these attributes and see the effect it has on routes. Here's a few more pictures showing some of the common restrictions. We're looking at that low bridge again, sharp turns, flammables, going through, in this case, the Liberty Tunnel, and avoiding steep gradients. These are all things that the API covers. So let's try that demo out now. This is a quick demo that a colleague of mine put together the other day. Let me see where we've got it. Yeah, there we go. And what this allows us to do is look side by side at a truck route and a car route. So in red here for this location in Pittsburgh, you're seeing the truck route, and in green, you're seeing the car route. And interestingly, because of traffic right now, I generated this just moments ago. You can see here the Liberty Tunnel. There's probably a lot of traffic there because normally this car route would come through the Liberty Tunnel. But due to traffic at the time that this was calculated, they said it was actually better to go here. But the trucks still can't take that route, so you're going to see it pop up here. Let's try another address. I'm going to go for 800 Lake Washington. And let's go for 98122. So this is going to pop us over to Seattle. That should be drawn in on your screen. Yeah, here's a really nice example. Zoom in on this. And this one is due to a sharp turn, I believe, is the restriction that is being faced here. So the car can come, you can't tell looking at a flat map, but this is a very steep hill right here, and there's a very tight bridge that is basically a one-lane bridge here. And my 4-meter tall truck is not going to be able to make it, so you can see how the truck had to be routed around the outside here, and they both will arrive at the same destination, but they had to take a very different course. It's going to cost that truck driver an extra minute to make it there, but that's going to save him 20 minutes if he had tried going up that red route and got halfway up and realized, oh my God, I cannot continue here. I've got to now make this ridiculous U-turn that I'm not going to be able to make in my 18-wheeler to get out of here. So these are just a couple of examples illustrating it kind of visually, which I think helps. And I mentioned truck routing. We have available right now in 60 countries, and this is growing. This is our platform across the board supports over 150 countries. But for the truck attributes I mentioned, those 20 extra attributes, we don't have them for every road in the world. We're working on that with our data supplying partners. But right now we've got 60 countries covered with truck routing, and here they are. And this is all, you don't have to worry if you're trying to write this down. This is all on our website. I'm going to give you the links at the end. All right, so let's jump into the next new API. I'll go back into presentation mode here. And this is the distance matrix. This is a very powerful API. It's great for optimizing large fleets and mid-sized fleets. I'm going to give a few simple examples where it's a fleet of one or two, and you may not need something as powerful as the distance matrix for optimizing your routes. It gets interesting when you've got more than just a few vehicles and locations that you're working with. So basically, with the distance matrix, you can create a grid of travel times and distances between many origins and many destinations. And we'll give some examples there of why you would want to do this in a moment. This API does support driving directions, public transit, and walking directions. And someone asked earlier if our APIs use traffic, and yes. As a matter of fact, here we use real-time traffic. When you're calling this API, you can say, "Hey, I want you to calculate the matrix or the driving directions at 9 a.m." and we will use traffic at 9 a.m. Or you could say, I want to know what it's going to be like this afternoon at 4 p.m. You can pass that time in. We'll use historic data to look at what it was like at 4 p.m. and calculate the matrix that way. This grid of information that you get back can be used to solve some very complex logistics problems. A very common one is the traveling salesman problem. What order should I visit places in? But it really shines when you're looking at many-to-many origins and destinations. We'll look at some examples of that. My favorite is, imagine you have 3 commercial bakeries in a region and you deliver to 45 supermarkets every day. You're thinking of opening a 4th location to do some load balancing across your factories or your bakeries. Where should that 4th location be optimally? That's a commercial real estate problem, but it's based on your travel time and your deliveries and your logistics and trying to save money by saving fuel and optimizing your time and your delivery distance. So in this simple example, where you're looking at this very small grid of 3 by 3, I've got 3 locations and you can see them on the map. And I chose this example intentionally because we can all, as humans, we can just look at this and we can kind of eyeball it and say, if I had to visit location 1, 2, and 3, it's probably not optimal to go from 1 all the way down to 3 and then all the way back up to 2 just by eyeballing it. I'm probably going to go 1, 2, 3 or 3, 2, 1. And sure enough, when we pass these coordinates into the matrix, we get this little grid of times back, and I greatly simplified the response here. I'm just showing the time in minutes, and now we can clearly see that it would be ideal for me to go from 1 to 2 to 3. And like I said, you can believe your eyes here in this case, but in a moment we're going to look at much more complex grids, and your eyes will not be able to answer the question for you of what the optimal delivery order is. Now, there's a very powerful feature that we've also got as part of the distance matrix, and it's a histogram of travel times. So what that will let you do is, if you think of the default distance matrix as a grid, X and Y, like you're looking at here, add another dimension of time, a 3rd dimension, and we will return to you that same grid via the API in up to 15 minutes. What that lets you do is say, okay, I've got to make these deliveries and I've got to make them between 9 a.m. and 2 p.m. You can request the matrix from 9 a.m. to 2 p.m. in 15-minute intervals, and we will consider traffic at those 15-minute intervals and return the travel times. Now you've got a big cube of data, and you can run an algorithm over that cube and a large fleet throughout that 5 hour window. It's actually very slick, and we'll look a little bit more at histograms in a moment. So what are the scenarios? Who needs this? Who's using this stuff? Anyone who's trying to optimize routes across multiple origins and destinations. Obviously, in trucking and logistics, this is a very key capability. If you're doing delivery optimization, home repair, especially when you want to consider things like real-time location. Which of my technicians is in the best position to service 22 Main Street right now? If you combine the distance matrix with a source of real-time location of where your drivers are, you can very easily answer that question while considering the other jobs that your technicians out in the field are handling as well. Using things like public transportation analysis. We've worked with a company that does metro planning for where to open bus stops and optimizing bus routes. The two examples that we just looked at were a small, or we will be looking at in a moment, a small electric repair company. This is a really simple case where it's one driver and he just wants to optimize, I got 10 stops today, help me optimize them. That's a very simple case. And then we'll look at the more complex one where I talked about the commercial bakery. So here's the electrician. Eyeballing this one, it's a little bit tougher now. And this is still a very small grid, but it's easy to illustrate things with these smaller grids. You can see where this person lives. You can see the stops they have to make. We can pass all of these locations into the distance matrix. There's over 600 possibilities of what order he should visit these, but now you can run a quick algo over these, and we supply that algorithm in our open source toolkit, and you've got an optimized traveling salesperson route for this electrician. And then here's the bakery example. You can see I've got a commercial bakery in the north part of town and in the south part of town. And I've got, again, to keep it simple, I've only shown 4 supermarkets here, but imagine that there were 40 or 400 supermarkets through the region. And now you're thinking, okay, I want to open a third location. You could kind of eyeball it, but what if you wanted to be really precise about it and do some real load balancing so that one bakery isn't stuck baking too much product to service their supermarkets? Distance matrix can help you solve that problem very elegantly. And here's a look at a histogram using the predictive traffic. And you can see the 2 points on the map. That's obviously not the route from 1 to 2. We're just showing, hey, I want to get from point 1 to point 2. In Seattle, that means crossing one of our 2 bridges, the 90 bridge or the 520 bridge. And they have different traffic fingerprints. So if I request this histogram for these 2 points, and again, very simple so that we could illustrate this and make it clear, you can see what happens. You got time along the x-axis here, and you can see that when you're comparing Bellevue to Seattle and then back from Seattle to Bellevue going the other direction, you can very clearly see the time windows where things are going to get rough and your distance is going to go up. So you're going to want to optimize around those. The third API, this is one of my favorites, and this is one that I said earlier, people in other industries besides trucking and logistics are getting a lot of mileage, no pun intended, out of this one. And sure enough, they are. This is very useful in commercial real estate, in the insurance industry, law enforcement. Basically, what the Isochron API does is it takes an origin point and it takes a travel time. And in the illustration that you're seeing here, you can see these sort of concentric isochrones moving out from the center of Seattle at 10, 15, 20, and 25 minutes. And you'll notice they're not uniform. They're not circles because travel time over a road network is very different. We're not saying how far is 5 miles from this coordinate. We're saying how far is 10 minutes from this coordinate. These shapes will change throughout the day. If I calculated a 10-minute drive time from downtown Seattle at 9 a.m., which is rush hour, versus 1 p.m., which is much lighter traffic, I'm going to get a lot further at 1 p.m. So Let's see, did I miss anything here? I just want to make sure I covered all my bullet points. The Isochron API does support driving, walking, and public transport, just like the other APIs do, and it can consider real-time traffic or predictive traffic. Now, what do people do with this? Are they just for pretty pictures? No. The API returns the geometry, the outline of the shape so that you can draw it on a map, and that gives you a pretty picture to do data visualization. But since we return to you the geometry, you can also now use it in calculations for quickly spatially filtering. Here, we'll go to an example of that. Here you're seeing a screenshot of someone in the UK who is doing this for real estate, which is great for commute time. Very often when people are purchasing a home or renting an apartment, they want to be within let's say, a 30-minute commute of their office. So now you can put your office location in and say, okay, just show me properties. There's too many properties on this map. Just show me the ones that are within a 40-minute commute. And you can see I've highlighted them there. And I've listed some other scenarios. One of my favorites that I think really applies today is geofence generation. If you've got real-time location of where your trucks are, and you run a warehouse facility and you work in the receiving department, depending on what shipment is coming in, you may have to retool that bay to receive that product, whether it's widgets or gadgets that are coming in. So when that driver is 10 minutes away, wouldn't it be great if you can get an automatic alert that driver with this particular load is 10 or 15 minutes away, and then later a different driver is 10 or 15 minutes away with a different type of load, and you get that alert. So we'll look at geofences when we get to the real-time tracking portion of the presentation, but that's one of my favorite uses of isochrones, and you can see that I've listed a few others here that we just talked about. And here's an example. This really illustrates the property example again. On the left, a whole bunch of properties, but now I draw an isochrone on the right, and I can very easily do client-side filtering or server-side filtering based on that. So we had just put a little demo up on our website, and you can all get to this, but I'll show it to you real quick so you can play around with this. It's kind of fun. Oops. Get in there. So this is right on our Microsoft Maps site, microsoft.com/maps, and you'll see we've got some of the new APIs called out, in this case Isochrone, and we've got this little demo down here. And you can choose your travel mode. In this case, I'm going to say driving. I'm going to choose some points of interest, something that's a little bit sparse like grocery stores, and then I can move this slider and I can see the shape change. So this is how far from the center of the map, and I know it looks a little funny if I go like this, you'll see that it truly is the center of the map. At the center of the map, I want a buffer of 3 minutes of driving, and I want to just see grocery stores that are within that 3-minute buffer. And let's go for something like cinema, which is a little more sparse. And we'll move north up here. There we go. So that's a nice illustration. That's how far from the center of the map I can get in 9 minutes. And you can see that there's a cluster of cinemas here. I'm going to have to go a little bit more than 9 minutes to get to them. All right, so you can play with that offline. And the final of our new APIs is Snap to Road. Let me go into presentation mode here. So what Snap to Road does is it can take a series of GPS coordinates, which aren't always exact, and it'll snap them to the road, as the name implies. It'll return to you a legitimate route. You can see here that the blue pins were the GPS coordinates. We snapped them to a road, and now we have this tight red line here, which represents an actual route across the road. And for a lot of people, one of the very important things that this API does is it returns attributes about the road segments that it's been snapped to. So, for instance, you can find out what the posted speed limit is. A lot of trucking companies will use this API to sample points that drivers were driving, and they can look and see what the actual driver's speed was, but then they can snap them to the road network and see what the posted speed limit was. And they do this for insurance purposes where they have to do audits to make sure that drivers are driving safely. So that's just one example of what people are doing with this. Here's another example in the Windows 10 map app. You can take your finger or your stylus and you can draw on the map on your touch screen. You can sketch out a route, and it's an ugly route like that. But wow, now you can snap it to the road network, or they can snap it to the road network. The Windows application team, they're working on adding this feature to the map app right now. And then you'll get a legitimate route back. And then once you have that legitimate route, you can do things to it that you would do with a legitimate road network route, like measure it and route along it and things like that. So a few of the use cases I just mentioned: post-drive analysis, very, very common in the trucking industry. Reconstructing a route. If you're a runner and you take your GPS with you, it's very useful. Or a biker, you want to see it accurately on a map. You probably have noticed, looking at your runs or your bike tracks, you often wander off of the road, and this API will snap you back onto the road. All right, so that covers the new APIs. Now we're going to move into something that I'm very excited about, and this is the Bing Maps for Enterprise Fleet Tracker project. This was released in January, as you can see here, and we released it as open source. And we did this intentionally because we thought, hey, there's a lot of companies out there that need to do fleet management, but they all have very specialized needs, and we're not going to build something that works for everybody. But what we can do is the 80%, and that's what we tried to do here by building this project. And it's completely functional right out of the box. I'm going to show you how to deploy it in just 10 minutes. You can have a complete functioning fleet tracker, but more importantly, you have the code for that fleet tracking solution. You have the back-end code that can run on Azure or any other cloud-hosted platform. Since it's open source, you can take it and deploy it anywhere, and that gives you back-end services and a web-based dashboard. And we also have released, as you can see in the screenshot here, the application that runs on iOS and Android, and we've released that as open source as well, so you can customize it and tailor it. We have one partner that is taking this code right now, and they are compiling the applications, and they're releasing their own branded fleet tracker as a service, and they will have those applications out in the Android store and the iOS store shortly. But anyone can do that. And it's all built on the Bing Maps platform. So for all of your mapping needs, like map display, geocoding, reverse geocoding, that's all using our APIs. But again, you can, since it's completely open source, you can take it and do whatever you want. So here's some of the features. We'll look at a demo of it in a moment, but I just wanted to read out quickly some of the core features. So it's real-time tracking based on mobile phones. Right out of the box, we work with the mobile phones, whether it's iOS or Android. But one of the most common questions is, hey, well, can I use it if I've already got a fleet of trucks with GPS devices on board? Absolutely. Again, it's open source. It's really easy to integrate other sources of real-time location and then take advantage of all of the back-end features that we've built out. If you are using mobile phones, we made it really easy to register those devices by just shooting a QR code, and we'll take a look at that. So once you have your system up and running, if you have you're a local delivery company and you've got 10 drivers, they could do this manually, or you could just have them shoot a QR code, and that ties their phone into your private instance of the service that you're hosting. Right out of the box, you get current and historical view, so you can see where people are in real time, but you can also replay trips and look at historic trips. We do what we call trip and location detection. And if I go back on the map here, you can kind of see that. It'll be more clear when we go into the demo, but you can see that each trip has been color coded, and each location where a driver has stopped, we have some heuristics in place that detect a stop and how long they've been stopped, and then we reverse geocode it and we consider that a location. So there's services that are always running in the cloud in the background, analyzing the continuous stream of GPS points that are coming in, and they're trying to classify them as trips and locations. And that's what this feature is getting at. We have great geofencing, and this is really fun. You can create programmatic geofences, like let's say you have 10 warehouse locations across the region, and you want to create a geofence around each of them. Let's say you want to use the Isochron feature that we just talked about. You want to create a 20-minute geofence around each location. No problem. It's really easy to do that. You can also draw geofences interactively and then get alerts when a truck or a driver enters or exits one of those geofences. In the project, we exposed our truck routing API, and we do some simple truck routing, but you can extend that and do more complex logistics and planning things inside of the dashboard. And of course, we have reporting and analytics. You can see how many trips each driver has taken for a month or a week or whatever period of time, things of that nature. So there's a lot of good reporting built in, and you can extend it with your own. And that last bullet point kind of goes for all of these features. We give you a lot right out of the box, and you can get going very quickly, but it's really easy if you have a developer or you want to work with one of our development partners. It's really easy to enhance the feature set that's provided. So let's go over to our demo. I have done my quick deployment to Azure, and I've got myself and one of my colleagues at work are in this instance here. We'll find us. There we go. And this is me. You can see me right now sitting at my kitchen table at home here in Seattle. And you can see that we have filtered down to 3 days. I've had a very boring 3 days. My life has consisted of going from home over here to my office over here. And oh, look, on the weekend, I made it down here to the hardware store to get paint so I could work on the dining room. So that was my thrill. I can open this up from 3 days. Let's go to a week. And you can see that my life wasn't much better in a week. You can see I now extended all the way out here from my downtown Bellevue office. I made a trip out to Microsoft main campus. If I go out maybe 2 weeks, I did have some time off. I was in Las Vegas. Now I'm going to have to go out a month. It's been a while. So if I zoom out a month here, yeah, now you can see that I made a trip down to the airport. And if I zoom way out, I know I shouldn't have had my phone on, but I wanted to record my GPS trail as we were flying. And then you can see if I zoom in here, that was my time in Vegas. So we're taking a look at the historic tracking features. Now this is a very small fleet. It's just me and one of my work colleagues, Justin, and you can see him there as well. But the solution, as it's running on Azure in the cloud, scales very nicely, and you can add hundreds of trucks and devices in here. Now I mentioned, I just kind of jumped in and showed you me and Justin on the map, but how would you add another person in here? Once you've got your solution deployed, and I'll show you how to deploy it in a moment. I want to start with some of the fun stuff here in the demo. But once you've done your deployment, you'll need to add your phones. And that's really easy to do. I'm going to come over here to the menu, and I'm going to go to Devices. And I'm going to hit the Add button. And if one of you had installed the, I just thought this would have been a great way to do this demo. I could have had one of you, while we were talking, install the application. You could then shoot this QR code and with the application, and you would be registered. Your device would basically be in the system, and we could start tracking you. Now, if it's not practical for someone who's remote to shoot the QR code, and it usually is, you can even send a screenshot of the QR code. They can add this information here. They can get their device ID by looking in the preferences, and that'll let you add it manually. But shooting the QR code is really the quickest way to get someone added. And then as I mentioned earlier, for sources of non phone information, any source of real-time location can be easily integrated, again, because you've got all the source code to do that. But we focused on phones here to make it really easy to get up and running, tracking a mobile workforce. So we will not add someone. Come back to our main menu here. There was Justin down in New Orleans. Let's jump back up to Seattle for 3 days for me. And I'm going to show you the points here. You can see the frequency that the client is sampling the points. We've built the client. And again, you get all the source code for the client. So you could modify it, you could brand it, you could put your own features in. And yeah, you can see the sampling rate as I was driving around. These are the actual points coming in from the client, and the points are stored in real time, and a service is continuously analyzing them to try to group them together and decide what makes up a trip and what makes up a stopped location. I mentioned geofencing, so let's take a look at that. I've got a couple of geofences here. So I created one in my neighborhood. I called it the Theater District, and I just drew it on the map, and there's a couple of live stage theaters here in this little neighborhood, and you can see that if I edit it, I've got some attributes set, and so I want to send an email to this distribution list, which is just me in this case. I want that email sent whenever someone enters, and you can see I've got inbound or outbound. Maybe I want to know when someone is, one of my trucks is leaving an area. In this case, I want to get an alert when someone is coming inbound, and I've now got my available assets that have been registered here, and I just have that on my phone. So whenever I enter that theater district, I will get an alert sent to me saying, "Hey, Steve, you've entered this geofence." The cooldown feature is good. This is sometimes you get a little bit of GPS variance and someone is right at the border of that and they just entered the territory and you want to get an alert, but maybe GPS then says, oh, they're slightly outside or inside. There'll be a 3-minute delay, a little cooldown. We won't keep sending alerts, but then if you are back, if you've exited and come back inside within 3 minutes, we would send another alert. Creating a geofence is really simple. As I said, you could do it programmatically, and you can also draw one. And I'm going to draw one for you now. I'll just give it a fake name, and I'm going to make a big shape here. And that's it. So now I've got my geofence, and I could do all the same stuff that I just talked about. Maybe for Justin, whenever he leaves this zone, I want to get an email alert sent. And then, so once you've created the geofence, that's all you need to do. As you'll see inside of the project, there is a service running, a background process running in the cloud that then monitors real-time location, comparing them against all of the geofences, and it understands when it should be sending out those alerts. We got about 10 minutes left, so I'm going to move quickly through these last couple of features. This is the location area, so you can see these are all locations that the system has detected where the drivers in this fleet, which is just me and Justin, there's just two of us, but these are all of the locations that it has detected that we have stopped in this time window. And I can look at these locations. I can also do some reporting on them, which you'll see in a minute. This is where we've exposed the truck routing. And I won't show you that, but I can, if I have a truck in here and I choose it, there's my fake truck, I can set the attributes of that truck, and assuming that my truck corresponds to one of my real-time assets in the system, I can then route from that asset in real time to some destination that I set. We've got our reporting module here. Our settings where, our people settings down here. This is where I manage the people who are in the system, and I can give them rights to be administrator, etc. So everything that you've seen here is available right out of the box in this web dashboard. I haven't done any real customization here. I just took the raw source code and did the instant deployment. But it's real easy since we give you that source to go and modify as much as you like. All right. I see some questions coming in. I'm going to get to your questions in 1 minute. Let me get through my last slide here. So getting started with the fleet tracker, all of the source is here on GitHub. You can download it and deploy it, or you can go to our one-click deployment portal, and I'm going to show you that right now. And this is the quickest way to get going. Then once you've done that deployment, you just have to grab the mobile apps, install them on your devices, and you're up and running. So let's go back here. This is the deployment portal. And I should also show you the GitHub, which is over here. And again, we'll make these links available to everybody, but this is the GitHub where you can actually get the source, the documentation, and the link is also here to get to the deployment portal. And I'm going to go there now. So what I've done is I've signed in here. Previously, I've created an Azure account. So I said, hey, you can do this whole thing in 10 minutes. If you don't have an Azure account, that'll take you an extra 3 minutes. So you'd go create your Azure account. And then when you sign in, your subscription will show up here. Give your deployment a name, my fleet tracker, put the owner email. You need a Bing Maps key. We're gonna show you how to create a Bing Maps key in a moment. If you already have one, you just paste it in. Otherwise, you go to our portal. There's actually a link here to go create one, and that also just takes 1 minute. You would then create an application ID. You can do that here. I won't click the link in the interest of time, but that also just takes you 1 minute to get an application ID and an application secret. And then optionally, this is optional down here, to get the email alerts, the source code that we provide uses a mail provider called SendGrid. And if you have a SendGrid account, you can put your API key in here with your SendGrid email address and deploy it. If you don't have a SendGrid account, that's fine. You can deploy anyway. If you want to get alerts through email or text messages or pop-ups on a phone, you could write the code to implement that yourselves. But right out of the box, we supply the code that shows you how to send an email using SendGrid. And it's really easy to hook into the code and modify. And that's it. Once you've got all of this information set, you would hit the deploy button. I've already done it, so I don't want to mess up my account and hit deploy again. But you'd get a little wait timer. It takes about 5 minutes for everything to get set on Windows Azure. And you're done. At that point, you've got the same dashboard that I just showed you, and you would go ahead and start registering your phones in there, and you can have your small fleet up and running in no time. We've got a number of ISVs and partners that are taking this project, and they're deploying it themselves, and they're going to make it available to customers. So if you don't have developers on your staff, but you have a small fleet, you can get in touch with us and we can hook you up with one of our partners that will set up a deployment, a private deployment just for your fleet on your behalf. All right, and sorry, I'm moving quickly because we are down to 5 minutes, but I want to get to, this is honestly my last slide down here, and this is the getting started slide. So if you like what you saw today and you want to try any of this stuff out on your own, the first thing to do is create a developer account, and that just takes a minute at our Bing Maps portal. You sign in and you can grab an API key. It's free to do so. We provide pretty liberal limits on your usage for evaluation. With that key, that same key will work with all of the REST services and the map control. Basically, everything that you saw today works with that same key. We've got an interactive SDK. This is a great way to, and I'll click the link here. This is a great way to explore the capabilities of the map control. Wait for it to pop up. There we go. So basically down here, you got everything you need. You want to load a basic map. You're going to see a map pop in here in a moment. And lo and behold, it is just one line of code to do so. So you get your JavaScript code right there. If you want to do something a little fancier, like you want a dark map style, you can see that the developer here loaded the map and used one of the built-in map styles. You could do things that are more complex, like I need to draw a styled polygon on the map. It's not the prettiest polygon, but it's showing you the code of how to do it. That's the important thing. And everything is organized by topic. Here's the heat map that I talked about earlier. One of my favorite features. There's a default heat map, obviously with just fake data, but you can load your own data into the heat map and it'll draw that out for you. So lots to explore there in the interactive SDK. Basically everything that you can do with our map control is detailed there with nice, concise JavaScript samples that you can grab. We've got a link here for our extensive documentation on MSDN. I've got a link to the GitHub where we just looked at the fleet tracker. And one more time, I'll plug that we will be at the North American Fleet Association show, April 24 through 27 in sunny Anaheim, California. And if you're around, we'd love to have you stop by our booth and join us. And I saved a couple minutes for questions, so let's pop back here. It looks like a bunch of you were asking questions as we were going. Let me get up to the top. Audio. So for which countries is the API available outside of the US? On our website, we've got a very detailed list. If you go and do a search for Bing Maps Geographic Coverage, there we go. And so what you'll see here is a table of all the countries that we cover, and you'll see what level of geocoding that we cover them in. So looking for an example, Thailand, we do address level geocoding as a, for instance, that was the top of that, geocoding precision and road and data walking. So that'll show you at a glance every country that we cover. This distance matrix earlier in Singapore. So okay, Sonia, with an error on the distance matrix in Singapore, my email address is going to pop up here at the end. If you can send me the details on that, we can certainly certainly look at that. I'll look at it, or I'll have one of our engineers find out what your problem was. If you had two specific points that you were using, or a series of specific points, let me know what they were. We'll take care of that. Our data supplier partners, we work with a number of providers worldwide, the largest of which is a company called Here, which many of you are probably familiar with. We also work with the OpenStreetMaps data and some smaller regional providers as well for both our vector data and our aerial imagery. Multi-drop route optimization. Yes, that is a feature that we're working on. We haven't announced that yet. But I will, since you're all fortunate enough to be here with me today, I'll announce that it is something that's being worked on. And if you follow our blog, we will make that announcement as soon as it's available. But we are looking into that. And let's see, traffic awareness. Yeah, and so for traffic, it is both real-time and historic heuristics, live information. Yes, it has live information. And what we do for the historical data is, hey, you can build up a library of what travel times were and what conditions on a road were at any given time historically. And that's what we do. And that's how we calculate our historic traffic and weigh that into calculations like in distance matrix and the Isochron. No problem with routes of 40 drops for sure. The distance matrix can crank right through that. I wish I was a programming pro. I'm okay, and I can certainly help you out with code issues. But boy, I wish I was a programming pro. Um, multiple data sets. Yes, and so for Chris's question here, you can absolutely do that. If you have on your side, you don't have to upload all of your customer data to us. You can call the Isochron API, get back that geometry, and then in that sample that I showed you earlier, if you view the source of that page, it will show you how to compare each of your customers' locations to see if it is inside or outside of that shape. And if you have a question on that, or need that link, my email is going to pop up on the screen in just a moment, and you can email me a question. Let me pop that up now while I'm getting the last questions out of the way. Oh, it's blank. You can't email me. Just kidding. I think we have it up here at the beginning. There we go. Mail me at, if any of you have questions that we didn't get to because we are just over time now, you can email me direct at stevelum@microsoft.com, and I'll do my best to answer and get back to you quickly. If you need any of the links that we were talking about, write that down because I'm going to skip to the end again. stevelum@Microsoft, and these are the core links that we talked about. And I think we can let's mail these out. Everyone that's on here, I think we can now send a follow-up mail. Folks from Gray Matter that are on the line, is that the case? We can do that. I don't want to promise something that we can't do. I imagine that we can mail everybody out these links.
Gray Matter?
I'm going to assume we can. We've got the technology. We know how to do email.
Yeah. And I'm assuming we'll send out the presentation as well?
Yeah, we can certainly do that. I was asking
Yeah.
more about for privacy reasons when people signed up, maybe they weren't signing up to receive follow-up mail.
Oh, no, I understand. Julie will be dealing with that, so I'll get her to send a follow-up. Yeah, she sent a message. Hi, all the links will be mailed. The presentation has been recorded and the link will be sent to them too.
Awesome.
So you can press stop on your recording now, Steve.
Oh, okay. Let's see how I do that. I guess